National Electrical Code Section 230.49 mandates that underground service entrance conductors must be protected against physical damage as outlined in National Electrical Code Section 300.5. This section addresses various aspects of underground installations, focusing on safeguarding conductors from potential hazards. When an enclosure is subject to physical damage, National Electrical Code Section 300.5 requires the use of rigid metal conduit, intermediate metal conduit, or Schedule 80 polyvinyl chloride conduit. This protection must extend to a point 8 feet above finish grade. The requirement is also restated in National Electrical Code Section 230.50. National Electrical Code Section 300.50 specifically addresses conductors emerging from the ground. It stipulates that these conductors must be enclosed in listed raceways. For raceways installed on poles, the code mandates the use of rigid metal conduit, intermediate metal conduit, or Schedule 80 polyvinyl chloride conduit extending to a height of 8 feet above ground level. The question of what locations are subject to physical damage is crucial for proper installation and code compliance. Several locations are inherently vulnerable to physical damage, necessitating the protective measures outlined in the National Electrical Code. Firstly, utility poles and service poles are prime examples of locations subject to physical damage. These poles are exposed to a variety of potential hazards, including vehicle collisions, weather-related damage, and accidental impacts from equipment or machinery. The risk of physical damage to conductors running along or up these poles is significant, making the use of rigid metal conduit, intermediate metal conduit, or Schedule 80 polyvinyl chloride conduit essential for protection. Secondly, service installations mounted on meter structures are also considered locations subject to physical damage. Meter structures are often located in exposed areas, where they are susceptible to impact from vehicles, equipment, or even vandalism. The conductors connected to these meter structures are therefore at risk of damage, requiring the use of appropriate protective measures. Thirdly, service installations mounted on buildings are also subject to physical damage. While the building itself may provide some degree of protection, the conductors running along the exterior of the building or entering the building from underground are still vulnerable to various hazards. These hazards can include accidental impacts, weather-related damage, and even intentional damage or vandalism. Therefore, the use of rigid metal conduit, intermediate metal conduit, or Schedule 80 polyvinyl chloride conduit is necessary to protect these conductors from physical damage. Therefore, the conductors emerging from the ground at all these locations require physical protection up to 8 feet above finish grade. Understanding the specific requirements for each type of raceway is essential for ensuring compliance with the National Electrical Code. Rigid metal conduit offers the highest level of protection against physical damage. It is a heavy-duty raceway made of steel or aluminum, providing excellent resistance to impact, corrosion, and other environmental factors. Intermediate metal conduit offers a similar level of protection to rigid metal conduit but is lighter in weight and easier to install. It is also made of steel or aluminum and provides good resistance to physical damage and corrosion. Schedule 80 polyvinyl chloride conduit is a type of plastic conduit that is thicker and more durable than standard polyvinyl chloride conduit. It provides good protection against physical damage and is also resistant to corrosion and chemicals. When selecting a raceway for a specific application, it is important to consider the specific environmental conditions and the potential for physical damage. In areas where there is a high risk of impact or abrasion, rigid metal conduit or intermediate metal conduit may be the best choice. In areas where corrosion is a concern, Schedule 80 polyvinyl chloride conduit may be a better option. It is also important to ensure that the raceway is properly sized to accommodate the conductors. National Electrical Code Section 300.17 provides guidelines for determining the appropriate size of raceways based on the number and size of conductors. Additionally, the raceway must be properly supported and secure to prevent it from being damaged or dislodged. National Electrical Code Section 300.11 provides requirements for supporting and securing raceways. The installation of underground service entrance conductors must also comply with other applicable requirements of the National Electrical Code, including those related to burial depth, conductor ampacity, and grounding. The minimum burial depth for underground service entrance conductors is specified in National Electrical Code Section 300.5. The ampacity of the conductors must be sufficient to carry the load served, as determined by National Electrical Code Section 310.15. The grounding system must comply with the requirements of National Electrical Code Article 250. Careful attention to these details is essential for ensuring a safe and reliable electrical installation. Ignoring these code requirements can lead to serious consequences, including electrical hazards, equipment damage, and even fire. The electrical codes are in place for the safety of both people and property, which includes proper installations. The selection of proper materials and protection methods are required to prevent hazardous scenarios. Remember to use the proper safety equipment and utilize a skilled professional when performing electrical work.